So for this video, we're going to take a step back from these VEX specific commands and talking about autonomous and user control, and going back towards more basic C++ stuff that you need to know. Because this is all fine and dandy, right? You can make an autonomous with a bunch of these and a user control with all of this. But if you want, for say, like skills autonomous that takes a minute to run, now this thing might be like several hundred lines long, and if you wanted to use things like sensors, which I'll talk about in the next video, that it will get even more cluttered. And especially if you're using the same like movements or commands multiple times, it can get very repetitive and hard to troubleshoot. So today we're going to talk about declaring variables, declaring functions, and parallelization. So let's get started. Alright, so first of all, we're going to start with declaring variables. Now, this might not seem too important with what you've been doing so far. You haven't really needed to use a variable in any of these per se. But once we start working with functions, variables will be extremely important, especially if you want your functions to be multi-use. So a function can be declared anywhere in the code pretty much. But where you put it in the code will change what scope it has. And a scope basically means where the compiler recognizes the variable. Yeah, where it recognizes the variable. So if we put it outside of any of these brackets, just inside of the blank space, it will be a global variable, which means that it will work if you reference it inside of the autonomous, or if you reference it inside of user control, it will still recognize it. But if we were to say to put it inside of user control, it would only work inside of user control, and if we try to reference it in autonomous, we couldn't. It wouldn't recognize it. So for now, we're just going to make a global variable, so which means outside of these code blocks. And there are different types of variables you can make. The most simple type is an integral data type, or an integral variable, sorry. So we can just make one like that. So this declares x to be an integral data type, which means that it does not have any decimal places. So now, if we wanted to use this in autonomous, we could just write x there instead of 100, and then if we set x equal to, let's say, 200, right there, this x when run would basically mean 200 to the command. So this way we can input values to a command without really knowing what they are yet, which is extremely important, because that way when we start making functions, we can make them for a wide range of uses, and we can just input the values we want it to run to later, instead of having to worry about what they are now. So there are a bunch of other data types as well. Double is one you'll use a lot. This is basically a data type that has decimal points, and this is like, it can hold a wide range of numbers. I think it's 8 bits of numbers, I believe. So that's some crazy number in Arabic numerals, converted from binary. So this one you'll basically want to use if you're using decimals. If you don't want to use decimals, just use integer, which is that. Of course, there's several other data types, like there's floating point, which is basically a smaller version of double. You won't really, yeah, I would just recommend using double instead of using floating point. That way you don't have to worry about size limits and everything. But yeah, also some more things to keep in mind. You can't create a variable that's the same name as one you've already created. Of course, there's some exceptions to this. So even if you want to create one with a different data type, it still won't accept it because it's the same one as this one up here. I believe sometimes you can get away with it if you do it inside of functions, like right here, like that. This one's only local to this function right here. So it's not really interfering with this one. So that's the only time you can really create a variable that has the same name as another one. Alright, so functions are essentially pieces of code that can be referenced to, and when you reference to that piece of code, it will run all the code inside of it. So it's a great way to consolidate commands that you repeat often, or if you have a set of commands that you want to repeat a lot, or if you want to make an aggregate command, for example, to like move forward, you can make these both of these commands just into one function instead of having to write all of it out. So it can save a lot of time and confusion in troubleshooting. So there are two main types of functions you can create. One of them is called a value returning function, and the other function is called a void function, which essentially does not return a value. So value returning functions are a little bit similar to variables, actually. You can use value returning functions in place of variables usually. And they take the same data types as variables do. So for example, if I wanted to create a variable returning function, or a value returning function, sorry, what I could do is I just do int x parentheses and then brackets, and then inside the brackets, when you have a value returning function, you always need to have it return a value. Obviously, it's part of the name. So at the end of each value returning function, we always have to put a return something. So right now we'll just do return 0. So I'll change this back. We'll look at that in a second. So this is the syntax to create a function. Usually you want to declare these functions outside of any other ones. So like this one, you'll want to put like in the blank space, not inside of any of these brackets. Therefore, it can be used anywhere. So if we want to, we can put like anything in here. We can put like this code in here, and whenever we reference it, it'll run that code. But value returning functions always return a value, so they're most useful for stuff like conversions or other mathematical things where you want to convert an input number to something different as an output number. So say a good way to use this is, say, let's use, we'll declare another variable. We'll do int y equals 100. And then for this value returning function, we'll do y less or y equals y plus 10. And then we'll have it return y. So what this will do is it'll take y, add 10 to it, and return the new value of y, which would be 100 plus 10. And that would be an x. So if we wanted to use that in one of these commands, what we could do is reference it like that. So now, right here, we're saying like run the function x, and then whatever its output is, which would be this return statement, use that in this function right here. So those are essentially the basics of value returning functions. So let's say you don't really want to do any arithmetic and or any conversions or anything, and you don't really need the statement to return anything. You just want it to drive forward, for example, and then wait a second afterwards. And you don't want to have to keep writing that every time you want to do that. So that's where void functions come in handy. So to make a void function, all you do is say void, and then the name of the function, so we'll do drive forward, parentheses, and then brackets. And because the void functions don't return anything, we don't need a return statement at the end. So all this will do, if you want to reference this, what you have to do is just make it a standalone statement. So we'll do drive forward, and then that's how you would run the code inside of here. So if we want to make the drive forward command actually drive forward, you can just copy this in here, change this back to 100. Now, whenever we reference this drive forward command, it will just run the code inside of here. And that way, it will, we don't have to write this every time we want to do the same maneuver. So this is where you will probably find the most use for predefined functions, is doing these like same tasks over and over again. Because if we wanted to drive forward 5 times, instead of copying this code 5 times, all we'd have to do is copy this and do that. And then we drive forward 5 times. So this is pretty useful, but you don't always want to go 100 degrees forward every time. Sometimes you want to go 200 degrees forward. Sometimes you'll want to go like 1,000 degrees forward. So you don't want to have to make a void function for every single possible degree you would want to go to, because at that point it would be easier just to do what you've been doing before and write all of the commands out like I have over here. So by combining functions and variables, we can solve this problem. So we can actually feed variables into functions when we declare them. So a way we can do this is we can declare functions inside of the parentheses, like so. So we can do integer degrees, and then we can also do integer speed. So now we can take out this 100 and replace it for the variable degrees. We can take out this 100 for the RPM and replace it with the variable for speed. And then we'll do the same thing in this one down here. So now, when we reference this function, we have to input the amount of degrees we want it to rotate. So let's say 250 50 maybe. And then we'll put the speed, which will be 75. And put the semicolon at the end. And now this will take 250, make it the value of degrees, and then these variables we put into the commands here will now be the respective values. So now, instead of just having it go for 100 degrees forward at 100 RPM, now we can make it go any possible degree value we want and any possible speed that we want, as long as it's going forward. Or it doesn't even have to go forward. If we make this value negative, it'll go backwards. And we can even reset the rotation, so we don't have to worry about adding up the values and everything for rotation. I talked about that in the autonomous video. So this is extremely powerful, and you can put as many variables as you want in here to make the code inside of the brackets as customizable as you want. So I could add you. By the way, you separate all the values or variables with commas. I could put wait time, and then replace it for here. And then I'd obviously have to add the wait time here, so we can do 2. And then now we can control how long it waits at the end. If we want more granular control, we can change this to a double value. And then we could do 0.75. So we could have it stop for only a little bit. So you can have, so this just took what would have been 5 lines of code and condensed them down into one command where you input 3 values that can suit lots of different use cases. And you can make this for a whole bunch of stuff. You want to make this for turning, you can just change one of these to negative, and then it'll go the opposite direction. You can make that a different function. So this is one of the #1 things that will help you out especially when you're making autonomous. So now let's say you want to drive forward in the autonomous, and you also want to raise the arm up at the same time. Now, you can technically do this with the start rotate 2 because it won't wait for completion, but if you try to do complex movements like going forward and then turning while still having the arm go up, you can run into some problems where sometimes the motor won't stop when you want it to, or it will stop, but then you have to wait to turn or something like that. So to get rid of this entirely, we want to tell the C++ language to run different codes at the same time. And usually this doesn't happen because C++ is a linear programming language, so it'll read all of this code in order. So it'll only run one line of code at a time. We can get around this by using something called tasks. So in order to use a task to run functions in parallel, we need to create a function. And these functions must be value returning. You can't use a void function with a task. So I'll make one right now. We'll call it int arm up. And then you cannot return any, or you cannot input any values to it either. So the parentheses have to be empty. And then we're going to put a return 0 statement after that. And then we'll just do arm motor dot spin, and do it for forward at 100% velocity. So this will just do that, and then we'll do a wait time here. We'll say it'll do that for 1 second, and then we need a break. Stop. Sorry. Break. Okay, so what this will do is I just made a simple function that will move the arm up for 1 second, and then it'll stop it. So we want this to happen at the same time that drive forward is happening. So what we'll do when we reference the function is we'll do something a little differently. So we'll do task, and then we'll name the task arm movement. And then parentheses, and then we'll do the function we're going to use, which is arm up. And yeah, so you'll do task, a random name for the task, and then the function you want to associate with the task. And what this will do is this task now processes these lines of code, but it won't wait to process these lines of code. It'll go right up to this one and start processing this line. So, and essentially what will happen is this function and this function right here will run at the same time, and the code inside of here and the code inside of here will run at the same time. So when you run this, the arm will go up, and the drivetrain motors will go forward all at the same time. So this is extremely helpful if, like I said, you have multiple motions at once. But it can also be helpful for stuff that you want to run in the background. Like, say you want a timeout system for like one of your functions. So it'll stop running after a certain amount of time. But you need a clock to know how long it's been running for. You can use this task function to make a clock that runs in the background. If you want a temperature sensor, if you want to run like a display that shows what the temperatures of the motors are, which I'll talk about more in the next video that I have about sensors. This is useful for that as well. So anything that needs parallelization, you'll use tasks for. So again, this is an extremely powerful tool that you can use. Do be aware though, if you run a lot of these tasks, it will bog down the brain. And if you have enough of them running, sometimes your brain can feel sluggish to respond to your inputs. Like you might feel some lag or stuff like that. So I haven't really experienced this too much. I have around in my code right now, I think around 4 tasks running, and then I have the actual code obviously running at the same time, so that would be about 5 things running at once. And I haven't experienced any real issues, but your mileage may vary, so just be aware of that. Yeah, but that's about it. This is definitely one of the more I guess syntax heavy videos that I've made, and this can be applied to a lot more things than the stuff I've been showing you before. So if you need any help with this, don't feel free to reach out, and we do have a Discord that you can join if you have any questions. You can ask them there, so I will link that below. But with all that being said, good luck, and I hope this helps you with your code.